not understand from the book. This is regarding emission spectrum, absorption spectrum, and there is no mathematics involved except you have to understand the things, because there are certain lines, absorption lines. How do we know that particular things are present in the sun? So now I will not take backward radiation, I will call it a spectrum. Or I write it is a spectrum, okay? Simple experiment you people have done. If you take a prism, I take again same prism, you take a prism, and you know white light comes like this. If this prism is not here, this white light will go in this direction. It will go straight because light is in the straight line. Because of this dispersive medium, dispersion is there. Dispersive medium means it breaks up light into various colors. So what will happen? This white light, it is a, since all lines we say like this, all parallel, so they merge and show as a single line inside. They find different angles of refraction. If one goes like this, and other goes like this. If you, this is red, and this is violet, and this is Vibgyor, and if you have a screen here, you will get the bands. If this is put a screen here, you get a yellow, and that in the order of Vibgyor. Okay, you get the colors here. If you take this backwards here, this is called angle of deviation of red. We call it delta R. And if you take this line, because violet is here also, so violet is going straight, but violet has come up like this. So if I take it back, not this line, this line backward, it will come somewhere here. This angle is called delta V. So delta V minus delta R is called angular dispersion. It is the angle through which the spectrum spreads. Okay? This you have to learn it. And if you have got two different prisms, for one prism spectrum spreads this much, I keep it here only, replace this by another prism, same size but of different medium, spectrum may get more deviated and more spread. So that we say the dispersive power of that spectrum is more. A spectrum which can produce more dispersion, more angular dispersion. So there is a quantity, okay, there can be one ray also in the center which is the yellow. It has also got a delta yellow. If I divide this by delta yellow, this entire thing is called dispersive power. You can get a numerical on this also. Dispersive power. The power of a medium to disperse, to create a spectrum, to deviate and disperse, both. What does the prism do? Prism not only disperses, means breaks the light into spectrum, it also deviates the light. Have you understood? Angular deviation of violet minus angular deviation of red divided by the angular deviation of the mean light, that we take a yellow. If you find a ratio, it will be without any unit. Okay? That's called dispersive power. And I will not be able to prove it because it is a lot of time. Suppose it has got a refractive index mu, and this angle is A. So you have to check it that delta is also equal to A into mu minus 1. Please check it whether this is right or wrong. This is for you to check. For any color light, angle of deviation which it suffers, okay, is given by the angle of the prism A, refractive index of the medium minus 1 bracket. You can use this also for numerical. Now, one exercise for you. Are you attentive or not? One exercise for you which you will not do here. This is applicable for all colors. You have to find W. Replace delta V here. A will remain constant for all three colors. A is constant, U is constant. So replace this delta V. Put here. Replace by this. Put here delta V. Mu V. Right? You write mu V. Refractive index for all colors is different. Replace this here then write delta R, A will remain there, mu R. Put here. Find one more expression for dispersive power in terms of refractive index of the colors. All colors do not have the same refractive index. It is different. And you can say, if I say refractive index, deviation is directly proportional to refractive index. If I tell you violet color has got a very large, instead of going like this, it turns like this, goes like this. So its angle of deviation is this much. It has turned from here to here. This is angle of deviation. For this, refractive index will be more or less. Refractive index is directly proportional to deviation. If I ask you, mu R is more or mu V is more, what is the answer?
Mu V is more. Because refractive index is more, sir. Because as delta is proportional to the refractive index.
And angle is more.
The angle of deviation is
You
more.
think correctly, but you think backward. It's also a good thing. You're very right. You're right. I would like you next time to tell me what is happening here. Now I'll remove this because I have to tell you a very, very important thing. That is about. So, what is a dispersive medium? What is the effect of a prism? If we put a prism in a straight light, it does two things. What? It deviates the light as well as it disperses. What is dispersion? Spreading the light into its spectrum, into its various frequencies. Have you understood? Should I rub it off? Why I am telling you? Because without this, you cannot understand anything. What I am going to tell you is now very important. Suppose there is a, try to understand. This is a prism. Now I will talk about there are two types of spectrums, emission and absorption. If you understand that, then you will understand what are one of our lines. How do we know that the sun has got so many elements? There is sodium on the iron with plus F16, plus 16. Ions are there, we don't know. How can you know? You will go and see. How do we do it? We do it with the help of the spectrum. So this type of spectrum, when a source of light falls on any dispersive medium, I will not make a black and white dispersive medium. In order to make you understand, let us say, if the prism on which the light falls, from this side, a spectrum is produced. This is a screen, now the spectrum is produced. Let us say, for this is a yellow light. This is a yellow light. Okay? Yellow light will pass through any dispersive medium. It can be anything. It can be a prism, it can be a spectrometer, anything. It can be a spectroscope. You pass the yellow light through a prism, you note that there are two yellow lights. You pass the white light here. I take white because otherwise you will not understand. This is the white light. The light goes like this. You note there is a color spectrum here. If I show you something like this, is a color spectrum. Violet is here, indigo, blue, yellow, orange and red. But in place of, you get band, violet band, indigo band, there is a continuous, this is called continuous emission spectrum. It's an emission spectrum. Because the light is coming from a source. Let us say this is the source of a light through which the light is coming. The light is emitting this source is emitting the light, and when I pass it through, its spectrum is called emission spectrum. In this case, I have taken white light, and I get a continuous spectrum. This is called a continuous spectrum because where one color violet stops, the other starts. There is no dark region between the two. There is perfect darkness here, there is perfect darkness here, but there are colors here. What do you note in case of white light also? If I now replace this with a source of sodium lamp, this is now sodium lamp. So it is not a white light now. What is this light now? Yellow light. You must have seen the sodium lamp, street lights. If you take its spectrum, you will find that nothing is here. It is totally dark. It is seen white here. Think this is totally dark. Where there would have been yellow in white light, we find there are two yellow lines. This is called D1 and D2 yellow lines. You have to find out the wavelength. What is called wavelength corresponding to D1. So what do we have done? We have taken white light, I showed you that there will be continuous spectrum. Remove that source of light and put in the sodium light. It is got sodium vapors through which we pass in discharge. It gives yellow light. When this yellow light is passed through a spectroscope, we find that this yellow light, there is not a single patch of yellow light. There are two bright lights. We call them D1. So this is totally dark. This is yellow. This is dark in between. This is yellow and this is totally dark. Now see what is going to happen. I put behind this one more big source. Big source of light. It can be any light. I am not putting them, just showing comparison. That this source is brighter than this. Okay, this source, its brightness can be controlled. It is at certain voltage, giving two yellow light. You have understood? What is here? Dark or white?
Dark.
What is here? Light. Yellow. What is there? Dark. What is there? Yellow light. What is there? Yes, my dear. I have kept a source of light before this, and it is not working. Now I start increasing its intensity. इसका grow बढ़ना शुरू हो रहा है धीरे धीरे. This is also a source of white light. It is also a source of white light. Now when I start increasing its intensity, forget about D1 and D2. Nothing will happen to its intensity because I am not changing the voltage here. Okay? When its intensity increases, it becomes brighter and brighter. We know that on this background, the spectrum is coming. Continuous spectrum is coming out. तो यहाँ रेड कलर आना शुरू हो जाता है. धीरे धीरे यहाँ पे स्पेक्ट्रम जहाँ पे ये लिखा हुआ है ना, spectrum starts coming, color starts producing here. When the intensity of this is equal to the intensity of this, these two yellow lines can be seen distinctly when this spectrum is faded. Spectrum due to this continuous spectrum, V, I, V, G, Y, O, R. Okay, it's coming more and more and more intense. When the intensity of that yellow spectrum of this becomes equal to this yellow, these two lines merge. Again, we have not taken this, we have taken this, we have not changing its intensity. So we are getting two lines D1 and D2 and everything is dark. We have put one more source here, its intensity can be controlled, we are increasing the current through this. It is becoming more brighter and brighter and brighter. We know that at these places the colors are generating. So below these yellow lines, D1 and D2, faint yellow spectrum is coming due to this, okay? When the intensity of this and this becomes equal, D1 and D2 merge into yellow line, which is yellow spectrum which is coming up, okay? But what happens when you make it more intense? This is the intensity of source becomes more than the intensity of, this is say S2, S1. This is S1, this is S2. When its intensity becomes more than this, what do you know? These colors become more intense. But where you had D1 and D2, we find there are now dark lines. Why? This is very important. If you understand this, then you can understand it. These D1 and D2 lines are called line absorption spectrum. What is happening? From here all colors are coming. Now I tell you, all colors, right from, let us say the wavelength is from 4,000 angstroms to 8,000 angstroms.
So,
Yes.
so when S2 and S1 have same intensity, then that these two colors will merge, the
Yes.
spectrum and the D1.
You cannot see that D1 and D2 are same.
Then D1 will be orange color or yellow color.
No, D1 and D2 same yellow color.
No, but
This
they
is
merge.
yellow line. This is yellow line. Dark here, yellow line. Dark here, yellow line. And spectrum is coming here. All so between dark and yellow is coming more and more and more intense. When their intensity becomes same equal to these two, these merge. But when this becomes more intense, ये bright हो गया और ज़्यादा bright हो गया. So in place of D1 and D2, those yellow lines, you see two dark lines.
So but जब merge होते हैं, then it should be which color?
Why is it yellow color? Merge it will be yellow, totally yellow. Yellow color from this source is coming behind, already two yellow. When the intensity becomes, these two yellow will merge. Have you understood? What happens after that when the intensity of this source becomes the intensity more than this? In place of the spectrum becomes more bright, more bright, more bright. But in place of D1 and D2, you find dark lines. dark lines is called line absorption spectrum. Why? Now see this. This is the total range of wavelengths coming out from here. Same coming out from here, where it was white. Yellow के अंदर we have only two. I don't remember the exact value. Maybe 5,000 something. Approximated to these two lines. Check it, because this D1 and D2, they can also ask you one mark question. What is the wavelength of the lines corresponding to yellow line of sodium D1, D2? You should know those values. Like you know the value of G, you should know the value. You should know the value of Stephen's constant. You should know the value of Hales constant. Okay? Like you know the value of Planck's constant. You know the value of. You should know what is the Lindbergh's constant. You should know what is the value of gas constant. What is the Avogadro number? If you have to learn physics, this should be objective.
So gas constant have three values, 0.082.
So they are in different systems.
Calorie.
We'll take that. P is equal to RT, NRT. We'll take that. When N is equal to 1, P is equal to RT. Then we'll see. P into V is the work. Work means energy, means joules, divided by the temperature. So you can find out whatever system you take, you will come to it. Okay? What I am telling you, why dark lines are here. If you understand this, I will solve it. This sodium is capable of giving two lines. Let us say 5001 and 5001 wavelengths. These two lines are here. Now, when this entire spectrum, in which these two lines are also here, colors start brightening up. This source of light, which is capable of giving out only these two wavelengths independently, will absorb the same wavelengths when it is placed after the bright source. Okay? Or you may say before. This is capable, sodium is capable of giving two lights, D1 and D2. Okay? Because sodium is yellow light, it doesn't give any other color. So we get through spectrum, it is not it is a line spectrum. So that is called line emission spectrum. If you put a brighter source than this and increase its brightness, sodium, which is capable of giving two lines independently, will absorb the same two lines here. The entire group of photons coming from here, this will absorb these photons corresponding to these two, and rest it will show. So here you won't get any light. This is called absorption spectrum. Line spectrum, emission spectrum is of three types. When line is given, line spectrum. When a group of lines are given together, that is called a band. That is called a band emission spectrum. Third is continuous spectrum. Line emission spectrum, how this will look. If this is a line emission spectrum, I am talking of line emission spectrum. This is totally dark, like for sodium, I get D1 and D2, two yellow lines. This is yellow line, dark, 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 yellow line, yellow. This is called line emission spectrum. But instead of sodium, you can take any other gas in a molecular form. Then you find that there is a band emission spectrum. One line is there, then intensity is less, then all these small lines are together. This phase is something like this. Then one more is generated here. Here is dark, here is dark, here is dark. But there is a band. What is a band? A band is a group of lines. So this is called a band emission spectrum because it has got some color. If it is in the violet area, it will be a violet color. If it is in the red area, it will be a red color band. Okay? And this will depend upon the constitution of the gas. Every molecule is capable of giving, every atom is capable of giving atomic spectrum, light spectrum. If a group of atoms are together molecule, they will give a different lines together will call a band. Third is called a continuous spectrum, like white light. So all colors are here, one after the other. V, I, V, G, Y, O and R. There is no darkness. This is called continuous. Now you tell. Absorption spectrum is the reverse of this. Is it possible to have line absorption spectrum? where these can be dark and light will be here, light will be here, or colors will be here, but here will be two lines. Yes, like I told you every time. So spectrum, which spectrum? Line absorption spectrum exists. Similarly, in place of band, I have just told you bands are like this. Okay. There can be darkness here, but colors are there. So even the band absorption spectrum will be there. But will there be continuous absorption spectrum? No. Why? Because that will be totally dark. Have you understood? So emission spectrum exists in C, and so this is over. This just I wanted to tell you. Now, how do you know that various elements in its ionic form are present on the sun? Same thing. If you know what is the constitution of the sun, you know. Sun is a star. Okay, you know that thing very good. Basically, it is made up of helium, hydrogen combined to helium, helium combined to higher elements. There is so many reactions keep on happening here. After the entire helium, hydrogen is over, helium is over, hydrogen changes to helium, helium changes to higher elements, everything is over, it will cool down. It will happen after about, let's say 5000 million years after. So sun, they say, is youth, it's going to, nothing to worry about. Our generation and so many generations to come. Now, sun has got two cores. One is, this core is called photosphere. And this is called the core of the sun, where all reactions goes on. So all type of frequencies are coming from here, here. Whatever elements are present here, which are capable of giving their own spectrum, will absorb. Light is coming from this inner part of all wavelengths. When they go into this relatively cooler part, then ions are present. Those ions will absorb their characteristics wavelength. And when suppose your Earth is somewhere here, light is coming to you here, you are here on the Earth, then photons which have been absorbed on this way, you will see the characteristic dark lines. These are called Fraunhofer lines. These lines, when seen on the Earth, tell us what are the elements present in the outer sphere of this. Okay? Otherwise, who will go to the sun and say that iron is there or helium is there or magnesium is there? You should find out. They can ask you a question on this. And the last part of that is the photoelectric effect. That you know, might I tell you within 1 minute what exactly happens. That why I am telling you, because you are supposed to know the mathematics. Without that you cannot do. There is photoelectric effect. There are certain materials which are sensitive to light. Light means not only light, to any radiation we call it. Oh, that is also there. Spectrum. You know the spectrum? Let's see. So we'll just check how much you know about the spectrum. This is the light. Light is from here to here. I just told you 4000 to 8000 wavelength. So wavelength is increasing here. So this is VIBGYOR. You cannot see beyond this. You cannot see beyond this. The next which you cannot see beyond this is after that is infrared. So after infrared there is one more. Radio wave. Whether these are TV waves or simply these communication waves, microwave, everything will fall here. On this side, violet ke saath which you cannot see is ultraviolet. After that, after that, this is ultraviolet. What is this? I am not asking you the frequency. You should know the name. X-rays. And after X-rays? He says this is X-rays. Okay. What is this? These are the gamma rays. Check it. I am right or wrong. What is this after that with high frequency? Cosmic rays. Even now certain rays are coming from the cosmos, we do not know. And some of the particles I tell you like neutrinos, They strike up and go up to 25 meters into 25 meters into Earth, neutrinos. We'll talk about later on. So you know about the spectrum. Again, when you visualize a spectrum, you should see a spectrum like this. If there is cosmic ray on this end, and on this it is the radio waves, then you should see again the frequency will go on increasing like this. If you keep this in mind, then it's okay. If you don't keep this in your mind, then you will not come to know what actually is happening with the wave. Okay? Photoelectric effect. If these radiations fall on photosensitive material, here is a photon, it carries an energy h nu, it falls on this, it goes deep up to this place. It has got energy. Here is an atom which has got an electron outside. This electron will take h nu entire, and first it will do some work to come out to this, because there is an attraction on this electron which has to come out. There is an attraction on this electron from all nuclei present, which is positive. It works.
It has kinetic energy.
Ooh. That I will tell you from where it will come. So this photon has struck this electron small here. It has made to come from here up to surface. This energy which is taken by this electron to come from the interior of a metal to the surface of a metal is called work function. And we generally denote work function as phi. Suppose this carries a 16 units of energy. So the photon has gone, given all 16 to this. It has spent out of 16, let us say 7 in coming from here to here. If this electron is luckily at the top, it has to have less. But work function for a metal does not change. Where does the electron go? Okay. So how much is left? 9. It comes out with an energy half mv square. That is called kinetic energy with 9 units. So this is very, very important. H nu is equal to phi plus half mv square, and phi is equal to h nu 0. Nu 0 is the minimum frequency of the light which should fall before threshold, plus half mv square. इस पे आपका वैल्यू आता है. If you learn this one, it is extremely small to learn. Photoelectric effect tells about the particle nature of the light. Like I take interference and diffraction also when you come in class, or even if your course finishes in a level, we will take up interference, diffraction, polarization, Huygens restrictions. These all tell about the wave nature of the particle. But this effect, if I take a wave of light coming, I cannot explain this. So I have to consider that light is like a particle. So photoelectric effect, if they ask you what does it tell about the nature of the light, that light waves like a particle. What else? Which are other more? Like interference, diffraction, polarization, Huygens construction, they all tell about the wave nature. And what are the particles, what other phenomena tell about the particle nature of the light? Photoelectric effect. Then there is a Compton effect, we call it. When an electron hits an electron, when a photon hits an electron, something happens. Zeeman effect. Stark effect. These are certain things which explain the and you know this famous equation. What is lambda equal to?
H by
For photon we write P only, that momentum of the photon. This is for photon, and lambda is equal to h upon mv. We write for all other particles. If there is a equation, find the de Broglie wavelength for a particle. Don't use this. Use this. You should know the mass of the particle, the velocity of the particle. Actually, you should know and do the calculation and do it. Okay. So this was the second part which I wanted to tell you, and the third part is also very. What is that? Last part. That you know, that I will not tell. Heisenberg's principle of uncertainty. You know that?
momentum and position cannot be determined simultaneously.
Why? Why? Why?
If it is moving,
Why? Suppose here is a. We discuss which effect.
Heisenberg's
Heisenberg's uncertainty principle.